I'm not wholly inspired today. That's why I think paying back some technical debt is a good is a good thing to do, and there's a few reasons for this. So what I've been doing while I was away, let me change this. What did I do? I opened a GNUS window, I think. I wanted to go to this, so that's my vterm, which is going to look a bit better on a dark background, actually. And so what I've done, let's have a look at all commits. So I've committed blah 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 support from language server before the language server protocol, which is what I'm going to be trying today. The README. So it's been pointed to me that the README had a lot of missing links. So I've come and addressed this. So now we have a bit of a warning saying that everything below is actually pretty deprecated, but I've left the entire story with the bibliography that is here. So now all the links are clickable if you want to learn something. So my support for the Haskell language server is this Nix shell. The Emacs is run inside a Nix shell, and it should work. And there's some things on the Emacs side. If someone is interested, just ask. I can sometimes share more about my Emacs setup, which I spent an unreasonable amount of hour customizing for, very little effect, apart from me not being able to use anybody else's computer and nobody being able to use mine. So that's good. Right, and finally, and that's going to be interesting for today, I did a very simple De Bruyne. Oh yeah, I need to run LSP twice everywhere for some reason. So here we go. Look at this. It has weird icons, but I don't think this is supposed to be purple, but whatever. So this is a code action. I can say, well, in that here I say is list and blah blah blah, and I can do this, and that added like explicit export everywhere, which is something that I don't actually want, but it's possible. What is already quite a success, sorry. So this is a bit of a scrap your boilerplate / uniplate library for De Bruyne syntax, and I'm going to explain how it works. Having my computer behave so differently from all others. I am far from done. It's becoming weirder and weirder by the day. It's very personal. I try not to do that too much so that I can still use other computers from time to time. I've met people that say I only use vanilla VI to do file edits, because then when I log with SSH in a machine on anywhere, I know VI is there and I'm going to be like in my element. That's kind of fun. Anyway, yes. So it's a uniplate sort of thing, like we've been doing all over the project. We've got yeah, Emacs. I can't do without it. It's too late. I'm poisoned to the core. No, I'm regularly considering how do I deal with my emails in Emacs and things like this, because when I write text and I'm not in Emacs, I feel very, very sad. Anywho, so I'm going to explain all of this in a minute, but the general idea is we have something to traverse the immediate sub-elements, which I call traverse subs. Yes, at the end of Star Wars Episode 6, someone says, "It's too late for me," and is proven wrong. He does say that. Right. So yeah, and then I define all of these other traversals generically. I'm going to come back to this in a moment and explain, because we're going to use this today. But first, I want to make a note. How do I get which pop-up window? The one, this one? This pop-up window? Oh, well, this one, which I've got a big one here that is, this is which key, which is a package. Yes, indeed. The one that was up there, the one with the red dots here, because this one I have no idea. It comes from language server protocol, but I don't know why it's showing right now. It's kind of weird. It only shows on the first character of this file for reasons unknown. And this one, so when you say right now, you have to understand that you're seeing things several seconds after me and after I speak, and then because of buffering and what? And you take a few seconds to type as well, so there's a significant time. So right now is really a very useful information. Anyway, yeah, so this one is which key, the other one is the language server protocol trying to tell me something about my file, but I don't know what it was trying to say. Yes, you type too slowly. No, of course not. Realize that when you make me see what you make me say, there's plenty of people that can watch this and don't know that we've known each other for years. Right, so I wanted in the to-do things to make a few comments. So that's being done, but it's not finished. Definitions. Well, if people watch this on YouTube, they don't have access to the chat. Abstracting over types, right. I've thought about it, and so trying to, oops, what is this? Trying to add a full-blown universe. I like how everything's jumping right now. Yes, so if you watch the recording on Twitch, you will have the chat. But if my export to YouTube is just a video, that is company. But right now it's just when it's popping up during text, it's not very informative usually. So to have a full-blown universe would bring us too close to dependent types. Ooh, that's interesting. And the problems there that we are trying to avoid. The vertical line is field color indicator, so that's FCI mode like this. I have it turned up for Haskell for historical reasons, but that's all. It shows you the column where it would automatically fill. And I don't know why. Oh, I see. It just doesn't understand the space. Whatever. Actually, if it was like this, let me check something. If I do meterq, okay, I can fix it with meterq. Whatever. It doesn't work that well. It's a new feature. I had it to be able to autofill in comments, but it's not perfect apparently. We're trying to avoid, however. let me show you a paper actually. Boop. That's the repo. It's not very interesting, but that's the paper I wanted to show. It's called, oh, sorry, of course you can't see it. So it's called Polymorphism is Set Theoretic Constructively. What it shows is in well-chosen topoi, you can make a model of system F that is just set theoretic in flavor, if you consider that your topos is a universe of sets. It's just that it's not compatible with classical topoi. So if you do this sort of things, you will be in a topos that negates excluded middle. And the way it works is the way it works is by choosing a set where there is a we'll call it U, which is stable by U index product. So U is the large universe in which everything lives, and if you take a product of U many things, then it's still in U. U many things in U, of course, and it's still in U, and that gives you a model of system F, which I think we can exploit. But we don't really want to abstract over just types, just because that's not really what we want to do. What we want to do is abstract over groups or abstract over monoliths. But we know how to do that from the ML word. We can do modules and abstract over modules. And the universe of modules is not bigger than U. Like it's something like U cross U cross U cross U any number of time. But a fixed number of time every time you do a module. So when you quantify over the instances of a particular module type, then you fixed U cross U cross U cross U. And because U is large, as far as we are concerned, I assume, though I haven't proved it, that U cross U is no bigger than U. And if you're stable by U index products, then you are also stable by U cross U index product. And that gives us modules. And of course, like everything that has a type is even smaller than U, and therefore no problem there. So we can quantify over modules, a generalization of system F. It does mean that groups and so on and so forth won't be first-class object, but we can deal, and we can quantify as part of our function, much like in system F omega, which I think is not like there's no problem considering this, but it's likely that because we're treating all this a bit like a set theory, we will have a proof of the negation of excluded middle, which I have no idea how to get, but that will be a challenge for another day. We probably have it though. Right, so that's the general idea. So based, Andrew Pitts teaches us that polymorphism is set theoretic constructively, that we can make a universe of types, U of types, which is stable by U indexed product. This means this gives a model of system F a la Church. That means with explicit type abstractions and applications. That's probably where we're going anyway. We can surely proof left as an exercise, generalize this to quantifying over modules, which will let us quantify over groups and such of a given type. The version number is 27. I don't remember how to check, but well, I guess version gives it 27.1. You have everything in the mode line. Why did you fear that? That is the latest on Ubuntu. Oh, I'm not sure. I'm not installing it from Ubuntu. Not yet, actually. I'm not in 20.10 yet. I should move soon. But I always want to wait about a month before it's done, so that, yeah. No, actually, this Emacs doesn't come from Ubuntu. I've installed it in another way. So, but I don't think like most of what I'm doing is fully working on 26. I don't think that's much of a problem. And I want to try this new GCC Emacs thing. Oh, the colon indicator worked on 24. But maybe I had to install it. I don't know. We can have a look. That's not going to work. Right, so here it is. You have to install it. You can see that because there's an ensure T here. That means download from Melpa. I can like we can like call me someday and we'll fix that up for you. So right, again, explicit module abstractions and applications. However, we won't just do functors like in ML. We want to have functions abstracted over modules. So that was my one thing that meant to write. Still don't know about for all intros. I wrote about distraction somewhere else. I think there are other things I want to share, but right now that's what I can think of. So. Very good. So that was my point. I've been thinking a lot, and I really want to move this tactic language to a Lisp-like language. It's going to be easier to deal with in separate files and to highlight and since we're doing sequences of things, like Lisp will not be a particularly syntactically heavy thing, and it helps, like it natively deals with optional arguments and this sort of things, so it will really help writing these things. So here we just have a bunch of semicolon. We could just have one parenthesis saying, oh, a sequence of thing, and we just chain them. There would be parentheses around all of these, maybe, but I'm not really sure why I understand. The dot here seems to be a mud bar. Defining GAC.type colon. And it's getting a bit crazy because of the template Haskell, I guess. It's fine. So anyway, let's go back to this. So we have to deal with multiple speaking hard, but I am going to manage. So we have multiple types in general in a language that are mutually recursive. You might have like terms and types possibly. You might have values, neutral terms. In my case, I have a handful. Like I have, like I don't have prepositions anymore. But if we go there, just this thing should shut up. So we have terms and we have R types, and they are mutually recursive. Let's do something first. If I'm like one of those things that like LSP support is using simple retry action. Retry is a syntax refactorer for Haskell, written in Haskell, that's customizable in Haskell and can be used from the command line. So I can say unfold prop that will replace prop by term everywhere. You can look at here. I'm going to click, and it seems to have worked. And now I should be able to remove this, and it didn't work. What? I thought it worked, but it didn't. I was looking at the wrong line. Let's have a look at messages. In plugging retry, expected bool, but encountered null. Interesting. What does it mean? I need something to be loaded? I think I managed to work with retry when I played around with this. Interesting, this. If I do this, let's try unfold in current file. That did work. You're welcome. I strongly advise that you use use package for your Emacs init.l file. It really tidies things up quite a bit. Well, still, we have at least term and R type that are, and maybe Bazel type, but maybe not. Yeah, use package. It's what I showed earlier. It's this macro here. I think it's loaded by default in Emacs nowadays. There's a weird lack of a parenthesis at the end of this. I don't know why this works. Oh, that's because I have more things here. Okay. Oh, that's pretty ugly. Okay. No, I think it works in 26 by default, but I'm not sure. And it just, you know, lets you pack together. It makes it just it makes your configuration less packety. So. Right, I don't think I need this, but at least I need these two categories. And how do I deal with that with a single type class? There are several ways to do this. One of them is exemplified by the multiplet package. So let's just pop it open for the sake. So this is from Russell O'Connor. It's pretty clever. So the idea is that you would make a record like this, one with one value, with one field per data type that you want to deal with, and each of them would have a function like this, and basically So if you have a P like this, then you can implement the class multiplet, which gives us a function from PF to PF for all applicative. That's a traversal if you look at it the right way. It's pretty clever, and I really like it. And then whenever you want to do something, you would project on whichever field the you can say term of, or like on like map subs.term and map subs.rtype, something like this. Which is good and all, but should also move the I types out, I think, because I don't really use them anymore. So we're going to do this as well as part of this effort. But it has a few problems. First, it doesn't let you. So if you look at the map things like map children, you see that no, this one is. It says, oh, map M. No, I just want map children. Here you say, oh, P of identity to P of identity. So you have to deal with the identity functor, because it's really hard to eliminate in that particular context. Like maybe you can with some HKD tricks. I don't know. All of these things, they're slightly difficult to define. You can't define things by coercion. So I decided not to do this. I decided to go another route, which you can find in many places. I've got some documentation on this, where I say that a term is of type G to star for some G. And G here is just the list of my syntactic category. So you would have expr of term and an expr of R type in our case. And you define things for expr, and therefore, instead of having this this record, you have a for all here. So say, oh, if I can, it needs to be a different E in both cases, because where things are instantiated, it's just shadowing thing. But say, oh, if for all E, ignore the context for a second, I've got a function from A to FA, or A of E to FA of E, then I can lift it as a function from A of E to FA of E again, it's the same type. Whereas, but it's like this is on, like this function is applied on every of the immediate children of our thing, term, expression thing. So one of the intriguing property of this is that I have one generic catch-all case. If you look at definitions, like, I don't know, subs is a good example, I suppose. If I look at subst, term, if I look at the subs term, it's defined as, in the variable case, I do something special because that's what I want to do. And in the, the for all case as well, and in the other cases, I just call term map subs. But there's also, that's unrelated. There's also, there's not yet a subs R type. So I guess it's a, oh yeah, there is. It was on top. And here, I need again to repeat that generic case. However, the funny thing about having a single type with different syntactic categories, which you can use a GADT to define, I'll show you in a minute, is that you have a single catch-all case, because you can call this one function on everything at the same time, and that is pretty neat, I think. So I think this will work fine. It doesn't work in the multiplate approach, because in the multiplate approach, to remind you, you have 3 functions to define, and there's nothing really that you can do about this. Also, all of my things here are defined as coercion. This, because of the for all, this does use impredicative type, which is currently considered to have no good semantics, and will continue to do so through 9.0. But in 9.2, when released, there will be this quick look impredicativity thing that has been merged last month, and that has an actual good semantics for this. So we just hope that we don't abuse it. So the context you can think is of being int, but there might, like in my main file, that's the number of lambdas that I have crossed since I've begun. The reason why it's configurable by G is that if you can have several kinds of variable, you could use int, :int, or some record, or something like this. And we're not going to show this put in practice much today, but what we're going to see is this the singular bind here, which is just a new type that does nothing. But the point is that when you find it and you're trying to define a traversal like this, this traversal, I'm gonna move this in the type class, which I'm going to do by just adding 2 spaces here. Good. It's not happy. Why? It is not happy and it's not telling me why. That is fantastic. Okay. Add a low ambiguous type. It's ambiguous. Oh no, it's just I need to remove these. Okay. Well, there was a proposed fix at least, though I couldn't see the error message. Note how it's saying, like the breadcrumbs here, I'm giving me like a bunch of names which might be a bit too much. I might want to simplify this a little. There might be configuration options. Then it's telling me, let me put that in full screen. There's in the module data generic De Bruyne, in the type class syntax, in the method traverse subs. That's pretty cool. Oops. Yeah. I want the vtem to be here. Vtem. Right. Right. So this is now part of the type class. That's because there's an error here. I don't know a generic way to define this. I don't remember what the thing was, but there was I just passed. Oh yeah, I passed an arbitrary context to this because this one ignores context altogether, and this arbitrary context is just an error because I don't have any value of type context A in general. I used to pass 0 in the other implementation. I assume that when I implement that, most of the time I won't be able to look at this arbitrary value, so I can put an error safely. But if I can, then I may want to define this a different way. Okay. So again, bind, I was saying, bind is just like takes a natural number in the type, and that is supposed to represent the number of variables that you bind at this site. Then you have a built-in traversal for bind that is defined here, which is a bit weird because of this no nat constraint that you have to deal with. The general idea is that usually this n will be a literal, that you know exactly what it is, so it's going to be discharged automatically. So this is just saying, oh, this is the n, but represented as a number, as a concrete number. So it's reified into all values, and we just add it to the current level, and we just traverse it. That will help us keep track, which I've been doing in comments before of this level thing. Yes, I haven't mentioned, but I haven't actually finished fixing, or I haven't started fixing the bugs in the super compiler that I've been doing for the last 3 streams. But I hope that so we're going to test this framework on the file that is fairly stable, and I hope that using that will help us also simplify that file and track errors more efficiently. So we are going to import this file. So it's called generic.de Bruyne. Data generic.de Bruyne. I'm going to just put it in the right place. Oops. As DB. Could not load because hidden package. So what we have to do here, which apparently I can't click, no. Code actions. No code actions, okay. We're gonna go to the cabal file in experiment, and we are going to have to add generic.de Bruyne. De Bruyne. Ouch. Oh, wow. Right, but he's not from the southeast of France. He's from the Netherlands. But yeah, it sounds almost the same. I sometimes hear people say one and mistake it for the other. So I'm trying to fix it with -v. Error, yeah, an error. It's very interesting. I seem to be in the next shell. Well, I can just try and see if Haskell language server is here. Yes. So I'm in the next shell. Okay. I'm out of camera because I'm just reading my screen very close. Expecting one more argument to A. Oh, I remember what the problem is. The problem is that this changes the order. Just adding traverse sub here changes the order of arguments. I'm pretty sure. Let's have a bit of a look about what we did to the arguments. So there was A, F, E in that order, but now they will be A, F, E as well. What? Expecting me. Right, that's supposed to be G, I think. Traverse subprime. Oh, no, that's A, yeah. Okay, A is supposed to take an argument. Okay. Let's compare to this one. Yeah, okay, there's just an extra argument, which I don't know why, but it's going to be easy to... That's all? Okay. Okay, that caused much more angst than it was doing. Speaking of which, another change that I made is that configures Magit to save whip files. So I can do Magit whip log of master, what I'm currently am. And if I go up there, you see I've got my autosave from a minute ago, 4 minutes ago, etc. Every time I save one of these files, then a commit gets made and I can just, you know, have a look. This one is the one we just did. Yeah. I think that's pretty neat. I configured it to keep the entire history and merge every time I do a merge. So I've got like a month of history for no good reasons except that I like it. Well, I don't have it, but I will have a month of history after a while. Okay. So now we have imported DB, and I'm going to write a bunch of things. Let's see what we can do. Oh, deriving will be crappy, I'm sure. Okay, I always see one of the problem with this approach, but let's see what we can do. First, we can do data entries equal term. I'm using all caps just not to collide with the one we already have in our type, and we'll fix later using the power of retry. So now we can do data expr. It takes G of type entries where, so we can take all of this. That's going to be fun. Right, and now we'll have to do to expr term. Expr term. Let me copy expr terms that I can know. I'm gonna copy this. It would be nice if I could just have a function to convert something to GADT syntax. I'm going to do them last, sorry. So we're doing something extremely fun. Okay. Oops. Okay. We can clean this space, clean this space. Okay. Now we have multiple declaration of each of these. So we are going to paste this here. This is not going to work. And term equals expr term. It's going to take a while to fix. And here as well, we might want to let me still commit something, because this there. Oops. This one is a commit. So if I do whip log here, we're going to see this commit here. So that's the one. You see there's a merge that has occurred, and this corresponds to my making a commit. Okay, oh, that's because I said data, but I want to say type here. I need the GADT thing. Oh, I need to revert this buffer. Is it saved? Okay. Could not load. Oh, that's going to be a problem. How do I deal with this? I can just kill this. And reopen it. No, I can't. Could not load. Could not load. Why is this? I think that's the one we want. Boom. No more flight check errors though. SP. Okay. And here we go. Oh, that is pretty nice. I don't know what the difference between these two things are. Let's try them both. That added GADTs. Okay. And if I do add GADT extension, I assume it's going to do the exact same thing. Right. I'll solve these things later. Here. So let's try that actually. Deriving eq of x per term. Deriving instance, sorry. Let's remove this. I really need to have a formatter that will deal with my, that worked. Can I do x per of a? It works as well, okay. That worked. It's pretty amazing. Okay, that was not that costly. I still have a warning that shows pink, and pink is best color. It's yellow here. I can remove the import just by clicking it. That's fantastic. Okay, I'm actually pretty happy about how that turned out to be. So now we're going to do R-type. So I can put a small comment here to help terms and props, which are the same thing. And here we can do R-types. And we're going to, there's really no code action here, yeah? or lens. Ooh. No code action. Okay. I could, where is it actually? It's in toggle, capital T, and there's one for lens, that's L. So I've got lenses, but I can't see them. If I look at lenses, I can see, like, for instance, here I could click this. It can do plenty of things. It's kind of nice to have lenses, actually, though we don't see anything here. So this is something that we want maybe to have someday, is a way to transform edit type from Haskell 98 to Haskell to GADT syntax. That would be quite brilliant, actually. Okay, so let's start here. Evidently, Haskell is way better equipped than I am for doing that. X per R-types. R-type singular. I'm going to do like the last time. I'm going to copy this. Oops, didn't need to. Oops, again. I do a lot of oopsies. That, and here I'm going to copy this. Note how it wants to just paste emojis for me. I can use emojis as variable types, I think. Apple needs to use as an operator, so I can use it not as, anyway. Sorry. So we don't need this. We actually don't need this at all because we have our deriving instance. We want this to be a type, R type equal X per of R type. Where's it? Here. Telling me. Actually, so it's still stuck there. And it has a few bugs. I want to check if it can fix this for me. Okay. Unticked and permitted constructor. I can't actually... there's no action to fix it, but it's quite easy. As time passes, because this thing is going to be used by more and more people, more and more fixes will happen. Some of them, like, I don't really know how to deal with this, but many people will figure things out. It's surprising that it actually works. Like, everything we've done so far works. So, kind of feel like making a special commit for this. Like a committable commit. Refactor. I'm going to fix the ordering over there. Refactor terms R type. Oh no. That is not, I think you're supposed to start with a verb when you're doing these things, but like conventional commit, but whatever. Terms R types are now a single GADT. That's a general trick. You can convert any mutually recursive data type as a single data type GADT thing. It doesn't actually need to be a full-blown GADT. I think, like in my I go to my web page. Let's be crazy. A while back, this is very small. A while back, I wrote this root in the syntactic bracket with Hugo Herbelin. And if you look at the thing, I don't remember where it is, but there's some place where... Do I have bookmarks? Oh, that's fantastic. type families, examples, regular types. Here I do one of these, so that's just basically a mutually recursive type encoded as a single one. And as it happens, these sort of things, inductive type families, they're a bit weaker than GADT, so you don't even need the full power of GADT for this to work. That's because, I think, because the type that we're using here is discriminable, I think then the power may be equivalent in that case, but GADTs also give you the disequality of types very often, and that, like, the fact that bool is different from that is something like nominal disequality, which is something you can't really, well, you can have, like, bool different from that is provable in Coq, but like bool is different from bool prime that is defined the same is not. So anyway, GADTs are a bit stronger than this. That was just an aside. Doesn't really matter. The point is, this is a general trick that exists in many systems, and actually, I'm pretty happy. This is taking like 2 extra lines compared to before. It's not much less readable. It's not perfect. It's got a bit of syntactic noise, but there you have it. And that worked out of the box, which I find fairly incredible. So now what we're going to do is to say that expr is syntax. So instance db.syntax. Oh, sorry, we're not going to do that quite yet. Well, actually, let's. We'll still start there. So db.syntax expr. So that will give me a warning soon, because there are some missing instances. I need context, so let's start with this. Type context of expr equals int, illegal type family instance, add type family extension. Oh, that reminds me of something. I said I would sort these in the commit, so let's do that. I really need to add a formatter. There are support for formatters in LSP mode, but I don't really know what it is yet. So one of the weakness of LSP, at least in Emacs, is that it's quite poorly documented as it stands. Like the thing works brilliantly when you know what did I do? I'm pretty sure I committed something I didn't want to commit. Right. So what we're going to do is we're going to revert this. All this. V. Yes. Temp. We are going to revert temp. Right. Then we can rebase, take that, fix up, take this. Okay. Well, that was just to remove the it's not there anymore. The syntax thing, and then we are going to revert mixed to there, and now we're back to all situation where we wanted it to be, and this is just okay. And now we can go back. Okay, there's no more flight check error because I scared it. So we can add a type family extension. No explicit implementation for. So what's missing right now is T. We're going to fix this. I've been at it for an hour, and from digression to digression, we're still at the beginning of the refactor. Okay, we are much better equipped now. So, we have all the right functions, which are traverse, or subs, maybe term subs, I think, right. I have a link to there in De Bruyne, right? No, I don't. A good explanation of the style in context of De Bruyne indices can be found at right, so I'm moving that over there so that I can remove it from here. I'm gonna be able to remove this entire section. So we can take term subs and R-type subs. Specialize. I'm pretty sure I don't need specialize, but because it's in the same module, so they just will specialize by definition. Yeah, I don't want to remove them just yet. So while we have a warning, we don't see if we're breaking something or not, which is a bit risky. So we're going to paste all this here. Okay. I won't need more of these. I'm just going to do this. So I can't. So now I'm inside the syntax. We're going to replace term subs with traverse subs, and we are going to replace R-type subs with traverse subs. We're going to have to inline this. This goes away. We can do as earlier. Intern prop, it's completely lost. R-types and terms prop. It's lost. It's interesting. Illegal type signature in instance declaration. I guess I can't have it at all. But it's not correct anyway, because that's not term. That is supposed to be for all e prime. Let's see if we can have one. Int to expr of e prime. We'll have fewer arguments as well. Here we have 2 arguments everywhere. I'm going to have a single one, which is going to take a little while to fix, but right. So f of x per e prime, and here we do. So we can remove this argument entirely. And here that's expr of e and expr of e. I think there's an instant signature thing. Let's have a look. GAC instance signature. I guess not. That doesn't look good. GAC manual. The manual. Yeah, I don't know. I thought there was a way, but there doesn't appear to be. I'm going to leave this as a comment for now to guide us. So here we're ignoring the. So, what are we going to do? We're going to replace. Well, these ones I can just kill that way. And then it's going to be a bit hard. So I'm going to call this on sub. And here, everywhere, we're going to replace on term by I wonder if there's a way to leverage retry to do this. On sub at term. Okay, not everywhere. Yes, yes, no, yes, no, yes, no, no, no. Yes, yes, no, yes. No, yes, yes, no, no, no. I removed the wrong one. No, that's good. No, yes. And now it's gonna, no, it's gonna be unhappy for a while, so. We want to say that we want to replace on prop. Similarly, by on sub at the same term. No, 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 yes. There was a single one. So there. Oops. Okay. And want to replace on R type with on sub at R type. Okay. No, yes, no, yes. No. I don't know. That was a bit confusing. No, 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 no. No, 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 no. Yes, yes. That's weird. Okay. Okay, I did the wrong one, but that's fine. No, yes, yes, no, yes, no, yes. One of them is weird. This one can I'm gonna do this manually because it's just too irregular. I guess it's not. We can okay, well, that's fun. Parse error input. There's something wrong. Here we have the same, but we can remove this. Okay. But on R type, on prop, with on sub. Well, that was fun. Yes, that's not the right type. Well, I think I'm going to remove this and just count on the compiler to do this for me. It's still unhappy about something. Does it look right? It does look right. Yeah. We haven't fucked things up yet. So it's still stuck here for some reason. I guess I can just revert buffer. But now our goal will be to define traverse subs, etc. in terms of these function. I'm gonna need a bit of a helper, I think. So I'm gonna define a function, pack sub, that takes functions. I'm gonna need a type for this. Int to I'm not going to keep it, so I can use this. Int to turn to this is not going to work very fine. Because I need a different one per function. Okay. Let me forget about this. It's not happy about something here. But the other one is, it's not perfect, is it? But it's fine. It's a bit lost. Term subs. Now the goal is to remove all of this and to replace it by a single function. fine. So what's the right definition for this? Because I need to repack the arguments, which is going to be annoying. Or I could just not and change the argument type. Deal with these one at a time, which might be wiser. If I do, so how do I pack the arguments? I need to say that, no, yeah, it's way too annoying. So I'm going to change the type. So here we're going to say the for all e prime thing. E prime to e prime. Here we're going to simply remove this. Here x per e. I don't know what it's complaining about. X per e. Legal polymorphic type. Okay. Why? So it's still complaining about the same thing. Not this one, but a legal polymorphic type. Perhaps you intended to use rank n types. Oh, that's just because I haven't used that yet. Okay. But it doesn't give me the fixing option? Oh yeah, it does. Okay. Sorry about this. Rank n types. Okay. It's not the right type. Yeah, it has this extra thing, which is annoying. I need to figure out how to remove it. Might take a while. Oh, really? That's really unfortunate. What? That can't be true. No, it can't be true. What's happening here? So Trevor subs. It takes the type G, which I don't care. Right, this one can be probably removed eventually. Probably 9.0. And then it takes this, it takes this type, and then it takes F, and then it takes E. Right. It's actually fairly unfortunate in order. all of these, I put E last. But I usually want to apply E first. So let's get things typing, and then we're going to change the order of things. So that's really something like this. Oh yeah. I'm changing the order already. Do I need something else? Nope, that is good. Oh, I see the problem here. It's just... So here it's term subs, so I can just... I'm supposed to say term here. That's how I... Oops. That's how I got confused. I'm doing good programming tonight. And similarly here, we can do this. I can format it the way it was formatted before. Here, instead of term, I have to say R-type. R-type. So it's equal. I could have just copied the other one. It's lost again. Revert buffer. I feel like I'm doing this a lot. Okay. So prop subs is also not the right type, but prop subs can be prop subs is term subs. So, oh, there's an extra argument, but I don't care. I'm gonna say prop subs is term subs. Oh yeah. Don't want to lens this one though yet. Okay, now we have more of these, but not so. Okay, this one. Yeah, we'll have to change all the types, so it's going to take a while, unfortunately. And this will be db fold subs. It's completely lost, no completion. At underscore at expr at underscore at term. Maybe it's not the right order. Meta you. That really worked. Okay. Maybe. full subs. There's monoid is second. Oh yeah, there's one fewer argument here because there's no type class. And the argument is inferred instead. Salties. Sorry, was saying this. So that's the same as the one I just did, except with full at the end, R-type at the end, sorry. Could have copied this as well. I just realized that term and R-type are already things that I've defined, so I don't need to rewrite them all. I can be a bit faster than this. It's taking a bit of a while. It's not very fun refactoring. So here again, you take this. And here, we can take this one precisely. That is not where I expected an error. Right. I don't care much about this, but we'll get it a type signature later. Temp subs, that's the same. Here we do for all E. Oops. For all E prime, X per E to F of X, oops, prime, X per E prime. We can remove all this. We can say that is db.traverse subs of add underscore, add X per, add underscore, add term. It's not happy. Cannot unify. 0 entries with X per E prime. Oh, sorry. I forgot. Yeah, I forgot to put the underscore. That's all. That is all. That is absolutely all. I'm wondering something. What happens if I do universal argument buffer? No, it doesn't work. I was wondering if I could switch buffer, like switch buffer to other tab. I don't know what that is. Other, it's other window, right? So if I do this, I do right. Okay, that's good to know. Learning Emacs. It's a pursuit of an entire life. So this is R-type sub, so it's the same thing again. for all e prime x per e prime to f of x per e prime. I can kill this, and this is equal to db.fold subs, not full subs, to db.traverse subs underscore add underscore add x per add underscore at r type. Oops. Nice. That was interesting how that happened. Okay, so I'm not sure what I was typing. So this prop subs prime, that equals term subs prime. So again, that has type for all e prime, f of e prime, no, x per of e prime to a, and that has type db dot db dot full subs underscore sorry, add x per add underscore add term. Okay. Prop map subs. This one doesn't yield an error in my that's kind of funny. Oh, this one is the one I was looking for. Okay. I'm just going to do them in order because I'm getting confused. Oh, would to check something. Wasn't it total line? 83 insertions, 72 deletions. So that's 10 extra, 11 extra lines really. But these lines, there's like, I'm not exactly sure what they are. These 3 lines here. There's a few lines for adding things. Okay, there's this line in there. So it's a bit longer, and these 3 lines. Yeah, I don't know. Anyway, R type full subs. Prop mat subs. So It's funny that this one in particular is giving it trouble. So for all e prime x per e prime to x per e prime, and that would have type db.mapSubs underscore add x per add underscore add term capital term. Interesting. Oh yeah, there's no middle one. Fantastic. This one is quite similar. Nope. Could just try and be a bit efficient. We get to this one at last. This one is the same as the term one. So we can just say term map subs. I don't know how I type this precisely. Okay. So now I'm going to do a whip commit. And we're going to go to the next problem. So we can't define these things that way now. I have to define them as a single function. And free vars colon x per e to ident. And so we can do this. Then we're going to do a lot of cleanup. Free vars of anything else is termfold subs underscore of free vars and of t. Right, because that's just right, and this temp free vars equals free vars, it's just the same type, and this one as well, free vars, and this one as well, free vars. Okay. So subs does the same thing, sort of. So we do have to define subst, which I hope doesn't x per e to x per e. Sorry, this is a list of terms. Definitely x per e to x per e. Subst of subst okay, that's pretty. I'm going to call it substitute. So this here, so and so the rest of the cases subst of t equals db.prop map subs no, sorry, map subs underscore of substitute subs and t. Right. And so this is just equal substitute. I think there's a case missing. The var case is missing, evidently. There are several cases missing. I haven't dealt with subst end prop, so I'm going to look at this later. R-type, there's this case that we need to add. Substitute, shift, subst. I think I can simplify this, but later. Now I just bang my it's complaining about a lot of things. It's a bit of a non-trivial factor. Substitute. I don't even have to specify the term all the time, so maybe I can simplify my definitions over there. Okay. And subterm here. There are two cases. Oh. One of them is already taken care of. Right, because that was the one from prop that was repeated. Okay. I'm going to revert the buffer again. I wonder if it leaks memory every time I revert the buffer. It's not impossible. So this doesn't have the right type because... Oh yeah. Right. The first is an actual term, but the other two we can write expert E. The subset prop is incorrect too. So we're going to start with the base case. I think all the other ones are trivial, but xt e equal db.mapSubs underscore, we ignore levels because it's a normal variable anyway, of substitute xt and of e. Substitute n. Oops. Okay, so well, there's a new version of Haskell language server that was released like this week, like yesterday or something. And that is all. Okay, so it's gone over the rails again. Let's see. Propose a fix. Replace with substitute n. I don't know exactly what spelling mistake I made, but couldn't see it. Okay. Add signature. Up. It doesn't manage to deal there, but it's not too hard. It's getting confused by the types, and this is looking very good. We haven't made a ton of progress, but we've been playing quite a bit. Oops, sorry about the noise. So Morty, you know, as we should. I didn't try to do something. I thought I'd try something. So if I move on to say this, it says, oh, it's defined blah blah blah. Oh, it was on my mouse, but if I go to definition, I end up on this definition. Now, what I don't know if what works is this also has a definition. It says, oh, it's defining data generics to Brian. There's no so there's a type here, but there is no documentation because I didn't write any, but you could have one. What happens if I press no definition found for? Okay, so you're not yet able to jump definition, at least not in 0.5.0.0 or 0.0.5.0. I don't remember exactly. You're not able quite yet to jump to definition between different packages, which is a bit of a pity, but you know, is life. As I'm saying, this is very early days. It's like a Haskell language server has been like usable for, I don't know, weeks, maybe a few months. It's very, very new. Plenty of features are missing, but it's only going to get better, especially because they don't have to deal. That's kind of the beauty of the language server protocol, LSP, is that they don't have to deal with the specifics of each editor, and therefore it works out of the box in VS Code. It works after some effort in Emacs and apparently less effort in Vim, or at least NeoVim. So everybody's going to benefit from this. Probably Atom as well, which is now also owned by Microsoft. So I wanted to just see. It's like I've fought with this, but I think this might just work like this. Well, it does. So I think I'm going to remove all of these. See, no bug. It's insisting on showing something on screen that is a bit distracting. I enjoy the pop-up, but right, we have a few more. That's actually pretty neat. That gives me good hope that I can just inline these. So that's what we're going to do next. Starting from the bottom. We're going to remove all the prop ones first. Maybe. I could just call the code action unfold in current files. It doesn't really work across files, it seems. This is done. I should now be able to remove this. Right. This one as well, unfold in current file. There's 4 diagnoses. Oh, no, these are code actions proposed, yeah. And this, 59. I'm not sure what this is supposed to mean. 59 what? I don't know what this is either. Oh. Now I've seen it, and I still don't know what this is. But it's this thing that happens. There's also an like a SPI menu thing. I don't really know. So you can you have this thing. You can. Can I? No, I can't type in it. I can move through things and say and press enter, and that would go there. I don't know what to do this, but just to demonstrate. Still have more prop things. There's more prop things here. No code actions. I broke SP again. I don't know what breaks. If it's Emacs LSP or it really doesn't want to inline that one. Okay, what if I move below? It really doesn't want to inline this one. Okay, what about this one? No. Aha, I can do this. Unfold prop subs in current file. Maybe it doesn't want to inline this one because it's not useful. The file is big, it's 2,000 lines long, so we're gonna break it down a bit, and we're going to extract things for fastness and overall not breakiness of things. We're almost done with prop. Can we oh, sorry, this appeared. Okay, so it decided that it doesn't care about this one. Remove all the prop ones. That's pretty good. Let's do the rest from bottom to top. Maybe. Unfold. Because I'm bold, I'm going to do the next 2 in one go. Okay. Okay. It's a bit mysterious where I need to put my cursor, but unfold. Okay. So the LSB actually keeps track of my what is this? I just don't know what it is. I did fold instead of unfold. Let me go. So fold does the reverse. Just I'm sorry. I'm not sure what happened. Maybe that was nothing and I should have ignored it. It was nothing. So here. That's convenient. But we're not quite done yet, because we have all these substitutes, etc. to remove. So where was that? Substitute. Oh yeah, there was 3 vars to start with. Let's go. Maybe. I'll remove this. Unfold, 3 vars R type. Unfold, 3 vars prop. Sorry, it appeared. Unfold, subs prop. Still looking pretty good. If we do anything wrong, we're going to break a ton of things, so I'm not particularly worried about this. Unfold, subs and prop. It's just okay. I can't get there, but there's been a bug. Oh. I think there's been a fold instead of an unfold. It should be fairly easy to check. That's good so far. That is wrong. No, that is not wrong. Okay, so that is wrong. I'm not exactly sure what happened. Okay, where were we? Okay, so I unfold this, unfold. Unfold. Fold. Subterm, we can unfold this as well. Fold. These are I-type things, which we're going to move soon. But I think we're done for almost done for a big refactor. Yeah, there's quite a bit of noise here. Not exactly sure how we can make that better though. Right, so that's what we were looking for. So I think we want to full term to unfold term, sorry. I'm going to remove term and have X per term everywhere is my plan. It's easy to revert anyway. I'm going to unfold term in the current file. And I'm going to unfold R type in the current file. Okay. Okay. That's pretty buggy. I didn't properly add parentheses. What is this? I thought it was cleverer than this. Okay then, I guess we can't do this. Really though? I'm not quite sure why this happened. Well, this is something that can be fixed. Maybe by calling retry manually rather than within the plugin. Small enough, we can do this later. refactor, remove the dedicated, well, use generate Brian to reduce traversal code. We're going to fold this. Oops. Okay, and now we can have a look at. Whoa. Let's check. But so it's 100 fewer lines. It's not great, but it's not bad. Oh, that's fixed actually. $100 fewer lines. So we are down to 1,700 lines. Oh, and we can remove this. I'm gonna add it in the thing. And state change. Okay. Maybe, oh yes, we said we would take the I-types out because they're basically useless. So I'm going to make an I-type file. Right, here the files, they don't have a, oh, it's complaining quite a bit. Defined but not used. Ton of things. Don't care. I removed all these warnings, but I guess they're not particularly respected. Okay. No, not B. Kill this one that seems to hurt with LSP on. And I'm going to make a night-type.hs module I-type where was it unhappy? Maybe because it's not in the cabal file. Let's add it to the cabal file. All the modules. I-type. Thinking, I'm not sure we actually need I-type for anything, but okay, so there's I-type here, so we can take this out and put it here. Now I need to import concrete, so it's not going to complain about that right away. Yeah, so having a formatter interacts very well with didn't I? Oh, there's two intern I-type. Oh right, there's the one with the empty thingy. It interacts nicely with a language server like this because when it does a code action, I can just count on the formatter to Right. Damn. Yeah. Okay. I'm going to be lazy. So because iType depends on the rest of the thing, it's not really legal to do this. I'm just going to move all the type that is not necessary. Okay. That's a long function that I can't deal with. So it's not very hard to break this cycle, just to find the things. Why do I... That's a bit crazy. I'm still using intrinsic type in these two. Okay, this one I can just remove. Why do I do this? Because I want the base type. What function does that have on the base type? Just this. Yeah, I want the base type really. So what if I do... I'm not sure what the comment's about, but... So... right, because that's... what's the type of type check? Environment type. the CCM of unit. Okay. So that's just so it's not going to be the right type, I think. Boom, boom, boom. Couldn't match type term with R type. Oh, no and. That works. I think we just need top constraint. But I think this code is fairly wrong. Throwing over the base type, that is T is essentially yada yada base type. Type constraint. Eventually we'll need this intrinsic type story because we are going to target the compiler that has a lower type. We might use the types somewhere. I'm not sure. But right now they're better stored somewhere else. Let me though do something just to make sure that I don't forget them. Here they are. I still don't know what top constraint does. Let me write top constraint and go there. That's interesting. Okay, so right, it just goes in our sub. That's perfect. Put a comment. I think this. I'm not sure that this comment is still valid. For strongly coerced though, we might actually want to do the I-type thing because they don't have to have the same base type. Which annoys me a little. Let's remove the 100 lines again. That's not many lines, to be honest. But I wanted to get this out of the way. I guess that's this definition of strongly coerce. To be able to It's funny that base type prime is written. I didn't actually write this, but that's nice. Okay. I'm pretty sure this is correct actually. So. I just want to say type checks are the base type thing. There are probably plenty of bugs. So I'm confused about this, and I'm inclined to say that we can't remove I-types just yet, which might mean that if we want to remove I-types, so all this was for 100 lines of code so far, and maybe this fix, which is good. My guess is that we'll have to break the file a bit smartly. I'm kind of unhappy about this, like this underlying I-types thing, and there may be a better way to do this. Not sure. I guess if underlying I-types is lazy enough, it's fine. So maybe it's not that much of a bad thing. I think though the type inference thing is a bit broken. I need to think about it better. Like inference, I think I should infer, like right now I infer types, but I think I should infer base types. But while I'm inferring base type, I accumulate knowledge, I think. Which might be contextual, so maybe I need to, I'm not sure. I need to think about it, but right now there's all the things that keep me busy. So I think we're going to revert this I-type thing to my dismay. There might be some unused functions that we should try to remove. What we're going to do is a bit of gitfoo, sorry. We're going to find this bit of code. That's my hunk. I'm going to stage this. Okay. And I'm going to unstage this. So I'm going to check. But this is what I want. It's very simple. It's much simpler than the fix that I had in mind because I don't know, I was somewhere else. Yeah, so I think the general idea is as far as things go, they have a single base type. They also have a single I type and several base types correspond to several I types. The goal is everything has a single base type and can navigate between different types of the same base type. And you can like coerce them to a more quotiented base type easily and to a less quotiented base type hardly. There's all this logic about dealing with the coercions, and I'm not sure what I should do yet. But actually, now it's easier to add some syntactic category that don't interact with the rest, so I could just do this and have some sort of, I have to think about it. However, right now I can just kill everything that is not Sage. Actually, I can just commit my thing. That's easier. Is even fix type inference of simple equality preserving course. And then we can just kill the rest. Also, thank you to our big friend Magit. Okay. Still no bug. So it seems that at least my library is correct. I haven't tested it at all yet. There's still quite a few things to do. Let's go to substitute because I'm pretty sure the definition is stupid. Okay, very good. So I can just... No definition found for substitute. What's happening? Reverb buffer. Yeah, so there's a new thing. No definition found for substitute. What? I think the file is too big and it's just breaking something. Here's the definition of substitute. Seriously. Yeah, there's another thing in town in Emacs land, which is often dubbed GCC Emacs. It's a branch of Emacs that instead of just doing byte compilation, just calls GCC. Maybe on the bat compile thing, I don't remember. I've seen a talk about it, how it's been done. Basically, it compiles everything to much faster functions. And so it's packaged in Nix, and I intend to try. It's not packaged in Nix packages though. You need an overlay, but I think that's fine. So I intend to try it, and maybe Emacs will be much faster, and that would make the whole LSP being slow a bit more tolerable. There's an error here where it doesn't seem to just lost, I think. Maybe I should just let's workspace restart. Okay, now it still say there's an error. If I say jump to, okay, it worked this time. Anyway, so substitute is a very silly function right now. So because it does the shift itself, and I could just use an integer for this. So I could define substitute, and so term the order of the argument is not particularly great, I have to admit, but we can fix this. It's not too hard. X per E. So we'll take these things. I haven't demonstrated a nice feature of so we need an integer. And so here we're going to do what's the function for iterating a function? Do you have to use repeat for it? Okay, that repeat works. Iterates a function right on a list, and then you have to take the nth element or something. I used sorry, I moved too fast. I used it several times. Oh, there's the Emacs conference coming on late this November, like in 2 weeks. There's quite a few interesting talks about interesting new things happening to the Emacs world, or newish, like the Emacs application framework, which I'd really like to understand. So what we are going to iterate is shift on subst, and then we're going to take the level element of this. So if level is 0, we're going to take no shift. It's not happy about something. Variable not in the scope. Shift. Replace with shift, please. There's something wrong. Preview X. Why does it have term to term? Shift is on term to term. Term list to term list. And subst is on term list. Ooh, of course. That explains it. Okay. And here we don't actually deal with the level at all. Yeah, we do actually, because we need to pass the level here. Because of course this doesn't change anything, but what I want to say is that substitute subst is substituted under subst 0. It gets in an inconsistent state very easily. Probably plenty of things that I need to learn to use, and it's still correct. Hooray! That simplifies substitute a bit. We can commit this, and then refactor, simplify substitution. I actually have an implementation of substitution that is a bit more clever in De Bruyne. It's quite inspired by Cox's implementation, that things can be a bit more efficient, so you have better shifting and lifting. It's like when you shift n times, you just add n to a number. It's really efficient, and it's sort of arranged so that composition is correct. You can compose two substitutions, which is very important if you're ever doing some explicit substitution. It's something that right. So it's something that is not completely obvious. If you do substitution lazily, like in Haskell, you would do just subst, and then whenever you move through the term, then substitution is pushed downwards, and so you pay for it progressively, and it's amortized. So substitution is O of 1. But it's not true if you iterate substitution, much like it's not true that iterating append on lists in Haskell will be O of 1 every time. If you do one append, it will be O of 1, but if you do n append, it will be O of n square. And the reason for this is that you're going to push the thing, but then you're going to sort of duplicate. In the case of substitution, it's much worse because you're going to duplicate your substitution. You're going to duplicate the effort of substituting the second substitution. Whereas if you would do that with explicit substitution, you would see the substitution, you would see the other one, would compute the composition once, and it will be shared between all the branches of your term. The cost of this, of course, is that you can't rely on the memoization of the lazy language. You have to code your own memoization if you need any, which in Haskell is quite unpleasant. And to be fair, Camel is not much better. So it's a bit of a missing bit in the language thing. It's a point that I decided not to talk about in my talk last week or so. Yeah, last week. The talk that killed my voice and prevented me from having the stream last week. Anyway, to give a talk at Haskell Exchange, and it's going to be online within like 3 or 4 weeks from now. And in this talk, this is one of the points to discuss, is that because I thought it would be too long, and actually I sort of went over time in that talk, so evidently it would have been too long, is that you sometimes want to program your laziness like this. You want to sort of to be able to do repeated function, to call repeated function, and that their effect composes in a way that laziness cannot handle for you. Laziness really handles very simple things. Anyway, this is a bit of a tangent, but if you want to do explicit substitution, the killer feature for performance is composition. So here you have a fairly efficient composition, I think. And I kind of like how it turned out, but I won't be testing it today. First, I need to move all this in their own module so that it has a namespace and I can import it differently. But it's pretty neat. It's a fairly simple thing. I think my implementation is a bit simpler than Cox, but it's mostly the same. I just think it's more readable because I implement take and drop, and it's also like it assumes that everything is infinite. So you can always say that a substitution is infinite by prolonging it with identity. So the general idea is here you have identity here, but it's not complete yet. But it's decent small library here that it would be one, more efficient, and two, would save me from writing these few lines, which honestly are not too much, but you know, it's also probably much more efficient. But there's a type class to write instead. I think I have this substitutable type class, which I don't know where it is. Let's jump to definition. Yay, it worked that time. So there's this class. You have to define what your variable is. So in that case, I suppose that there's a single. That's a simplification of the case. There's a single variable type. If you want more variable types, there's probably a bit of work to be done. And so you implement the subs function, which you can implement using the function there. They sort of recursively, and you can implement lift if you wish. But you can also, there's a fairly efficient implementation there if you don't need to by default. Okay, tangent. What I want to do is to start using bind in my syntax tree, which will probably break a few things, and then we're going to go to bed. That's sort of the idea. So what do we want? We want for all binds something, and it binds it here. Yeah, this has no extra bind variable, but this has an extra bind variable. That's for all. That's the name that we keep for printing of this type in this type. Well, in this type is this term, and this term happens to be true. So I'm going to add db.bind here, bind1. And then it breaks a couple of things. But before we do that, there's a couple others. The quotient is fine. Sub is the other one. And it also binds one here. db.bind1. And then we're going to go to the proposed locations. Okay, so here we do on sub of term, and we do +1 to the environment. We don't need to do this, we can just say env again here, and here we do this and db.bind, and it will do the exact same thing, maybe. And I need to refer the buffer. Okay, don't use too big buffers, I guess. I'm not sure that's the problem, but again, db.bind. Here, the rest will be extra complexity, so it's not as cool, but again, I think there's a synchronization problem really that's happening, that it's not sending, it's event based. You don't send the entire file. It's very easy to send a file that is not quite correct. I'm sure it's going to get better. It may already be better. So here I just need to add bind, I guess. Right, so here we can just add, nice, 247, db.bind. Whoa, it's proposing a lot of things. Can I write db.binds? Yeah. I think I should use, what has happened here? Is this a parse error? Yes, save things. Oh, it's actually a parse error. Yeah, there's a, ooh, okay, so it just broke. I can write it myself. And here, similarly, we want to do db.bind. There's a plural version when you want to bind on several things. Okay, so here it seems to be the same thing. I see that there's still references to prop. That's from extern, so we're gonna ignore this, I assume. The constructor p. My God, should have 3 arguments. It does. See, that's a good. See, it doesn't see the parentheses, so it just missed part of the change. So I think that what happens with LSP is that whenever the document changes, you will send a span of the document saying this span has changed, and then the server receives this and updates it and gets a new document model and acts on this by patching the document that it had. You don't send the entire file every time, probably for efficiency reason. But what we see here is that quite often these days, things get out of sync. Let's see if it works better this time. And it broke again. There are some consistent way in which it fails, but I'm not exactly sure what they are. I spend a lot of time. It's really my first time using it, yeah? So, but that explains why the parentheses were all wrong earlier. Where does this P come from? Here. I'm gonna have to decompose it all the time, but I think it got some parentheses wrong. I'm not sure exactly how and why. I think I have the same problem in I'm not sure that we gain so much time by where is this one bound? Here. Actually, like, look at this. I think I can just jump to it. Yeah, that's pretty neat, actually. Here again, we can jump to it and say, okay. And we revert the buffer. And we revert the buffer. I think it's still worth the time, weirdly enough. No definition, but I've seen it, so that's fine. Oops. So we have to deal with it a bit, which is rather unfortunate. But like that, it just takes care of the difficult part for us. And even when we take care of it, we sort of mark that we're entering a De Bruyne, so I think it's not that bad. It's a good marker. That was wrong. It's getting really lost. Yeah, that's a good point. I'm going to whip this. I'm not sure whether we've paid so much technical debt. I think next time I'm going to go and transform the tactic language into this Lisp-like language. I want to get rid of this. De Bruyne, bind, deriving, eq, deriving new type. I'm going to make sure. Illegal deriving strategy because what? Add deriving strategy extension. Right. That reminds me that we haven't sorted the thing in the other. Nah. Okay, maybe I'm not sorting exactly. I forgot to sort before I merged. So I'm going to ooh. It's not happy. Oh, I see. Okay. That is curious. Is that... It's completely lost. Okay. I think I might have hit an interesting interesting interaction between, like, it works-ish until it doesn't. AQ bind 1, despite the fact that I saved this, right? We can do GCI, and I want to load generic De Bruyne, and I want info on bind. It has eq a implies eq bind n a. So I think what's happening is that this is not properly loaded, and I just need to restart. I can just kill this thing. Yeah, I think what's just happening is that it's getting confused because it doesn't rebuild generic De Bruyne. So I think it's a bug in my .gcid. Right, so that was nothing. It's kind of miraculous that it didn't break before. Right. So there we have it. Now we have marked in the type where we bind values with De Bruyne's, which I think, like, most of the time we just look at it and we see, oh, there's a De Bruyne marked, and we have to deal with this ourselves. At least it's written there. You have a mark that tells you, oh, that's something that I De Bruyne. But you don't really write. You can't write in patterns the number, not yet anyway. But I could write : db.bind1, etc. But that's very verbose. Someday we could actually write the number of binds that we have, and like let the compiler check that we haven't written it wrong, which is kind of interesting. One way to do this, so there's some discussion right now about being able to have type arguments that are always explicit, and to have types in pattern. It's going to come together, but it might take a year or two. So let's not, be too ready, well, not too ready, but too expectant. SP workspace start. This workspace, got to run LSP again. And everything's fine. So I'm going to merge this, factor, use db.bind in expr. But yeah, so the idea is here that now traverse subs is pretty much like, it's just following the term, and it's just iterating. And now something that I'm wondering about this is whether we may, so as it happens, so let me go back to De Bruyne. I'm not sure yet, but so if I reorder the argument a little and I write things this way, oops. Okay, I don't exactly know what I did. And I write it this way, just for the sake of thinking about it. Oh, right, it's highlighting all the other occurrences of the thing, which it wasn't doing in the other file. I think it really misbehaves in big files, which is a good incentive for me a strong incentive for me to split the file into smaller files, which I can do, just don't really want to. But if I do that, I'll do that offline. I mean, today was not very exciting. Moving things across files more than once is going to be a bit of a pain. The point I was getting at is this is another F. It's a G, which is like reader of context composed with F, and it's also an applicative functor. So what I wonder is whether we could, you know, change things a bit, shake things a little bit here in the type class. Like we don't even have to bother with the environment. Like it will still not be the normal traverse because bind, the bind function, I don't know where it is, but here the db.bind function is here. It is not generic on the applicative, but if I write things so that it's really an applicative functor, I can remove and altogether, and this will look exactly like the traversal code. Can rename on sub into F, and you know it's going to be very, very lightweight. I can possibly remove all the add terms, all the add type here as well. Let's try that actually. To simplify a few things. I'm going to cancel this. Okay. And we can try. I'm going to stop soon anyway. But so let's take this and say like every time there's add term, all capital space, we're going to replace by nothing. Does this work? Does this work? This is working way better now. Maybe I was I needed a reboot of something. Like look at how things are highlighted, and the file is just the same size. I can remove it again. So we can remove quite a bit of the syntactic noise still. Okay, I did the wrong thing. With nothing, and boom, I still, there's one that seems to be failing. I'm not sure why. On Sui, no, it's still buggy as hell. Okay. So it really doesn't like big files, maybe, or maybe it's just all file after a certain amount of things. It's going to be fixed. There was just the one. Oh, there were two. And revert buffer. Okay, and so see that the syntactic noise is reducing progressively. Yes. I'm not exactly sure. One thing that is a bit sad is that we don't have the junction pattern to handle this sort of cases in one line, but whatever. So this gives the idea. It's a more robust thing. I think we're gonna. So what we're going to do, probably offline, because you know when I want to deal with this, is I'm going to rename these things like traverse sub 0 and traverse subs and 0 underscore whatever, and as functions that are just for the function definition. And I'm going to move traverse subs and traverse subs underscore down there, and they will have the same type as the other ones. I still don't know what the argument order should be, but then I will be able to have a consistent argument order independently of the binds that will not never be used, only used for definition. And I can change this into a reader T thing. Of course, it involves a bit of like silly rewriting that might not, well, probably will not often typically be optimized. So that's one extra closure, but we're not trying to go for optimal here. We're trying to go for good enough. And that thing, then we can remove the env here, have a single argument, and things will be actually quite a bit more compact. And therefore this will be like almost, it will, just follow the type definition. Like very, very closely. It kind of already does. But there's still a bit of syntactic noise that I think we can remove. But I think that will be for another day. Right now, we're going to take all this code that we've written, factor, remove unnecessary type annotation in instance syntax. Well, this is not a bad day. So there you have it. No, we're going to make a branch. We're going to say factor 2020 1113. Technically it's the 14th now, but most of the work has been done on the 13th, so let's do this. I'm just going to push it to upstream. I've also installed Forge recently, so let's just have fun with this. I'm going to check that we don't have any new issues or pull requests. We don't. So Forge is an extension of Magit that let me control things like GitHub, but not only, from my Emacs with, it's worth what it's worth. We want to create a pull request. So that would be CP based on this. That's what we just built. Target branch master. Any factors resulting of today's stream. I don't know why there's this line and another thing. Interesting typo. We use generic De Bruyne to reduce the cognitive, well, it's not really cognitive, but the well, the boilerplate, I guess. The boilerplate from to remove, not the, but remove boilerplate from the refine experiment package. Right, that's basically it. Like term and our type are now a single data type the distinction, yeah, between the two is given by a GADT argument expr to expr, and these also. Okay. Here, that's our description. I can do Control-C, and I have a new pull request, which I can, well, I could open in a browser, but it will open another browser than this one. So now it's appeared here, and we're just, no, we're not going to, sorry, we want to go to pull request, it's here. It's here with what I've written in my thingy. I should test whatever's happening in that template, because I don't understand. Like, I don't quite understand how it maps things. So if I have a single first header, it appears there. But if I have more, I don't know. Anyway, there's no CI here, so I'm just going to merge. Okay. Well, I guess that will be it for me. So it's been not very exciting, but yet interesting night, I think. Things have been learned about Haskell's language server, about there's the Broin thing. I think like I'm satisfied. The library was correct first try, which was not completely a given. A number of things got quite a bit simplified, which I think is nice. And you know, that will there will be less effort to maintain this in the future. This is not the end of the story. So I think that's what I was saying. Next time we're doing this, there will be sorry, that which will be in 2 weeks, presumably. Right? Yeah, like there will be times in December when I'm not here, during the holiday seasons, but not only. So anyway, in 2 weeks, we should resume this. I think I'm going to convert the tactic to a Lisp-like language, which requires one choice is how do we delimit an entry that represents a term. In double quotes, the string, and we need another delimiter to say, oh, within this, I'm using actually the term syntax, the expression syntax to parse things, and I'm going to get a term or a type. It doesn't really matter, something. And right, so we just use our normal parser, and this is, I don't know if we need one for types and one for terms. We usually input terms anyway, so maybe we don't care about that too much. I'm not sure yet. But we need a delimiter for that, and sort of in these delimiters, we would escape the syntax, which is bound to be interesting. Yeah, that's all for me. Video game next week. And yeah, that's all. So thank you very much if you joined, however, for short a time. I hope you enjoy the content. I enjoy making it. And yeah, see you next time. And until then, don't forget to stay curious.